Welcome to another session of Everyday Mathematics. Today's problem is problem number 9 of the MIT 2020 Integration P regular season set of questions. And it's the definite integral from x equals to 0 to x tending to infinity of x times natural logarithm of x over x to the power 4 plus 1. So interesting problem. Before we try to solve this problem, I'd like to thank our subscribers. Thank you so much for the support you continue to show us. It is your support that motivates us to come here time and again. To our first-time visitors, we do really appreciate your visit. What we do here at Everyday Mathematics is we go about and around and look for interesting problems. We try and solve them, and then we share with you the solutions that with these problems. To our repeating visitors, we do really encourage you to subscribe if you've not subscribed. So this is an interesting problem. The first thing that I would do is, as I said, I look for a more complicated expression and I use u to substitute that instead. So if u equals to natural logarithm of x, then du dx is equals to 1 over x. And what that means is that x du can be substituted for dx. And what is x if u equals to log x? It means that e to the power u is equals to x. So in other words, the expression e to the power u du can be substituted for dx. Now, in terms of the limit when x equals to 0, u tends to negative infinity, because when x approaches to 0, this log of x approaches infinity. So lower limit, x tends to u tends to infinity. Upper limit remains u tending to infinity. So the integration from x equals to 0 to x tending to infinity of x log x over x to the power 4 plus 1 is the same as in place of x to the power u in place of log x u in place of x to the power 4 is e to the power u to the power 4, which is e to the power 4u plus 1. And in place of dx, we have this e to the power u du. And we can consolidate this to e to the power u times the power u, which is e to the power 2u times u over e to the power 4u plus 1. Now, the limit, as I said, negative infinity to positive infinity. But now we can separate this integral into two parts, where we integrate from u to the tending to negative infinity to u equals to 0, and then from u equals to 0 to u tending to infinity, right? And therefore, what now that means is that these two separate integrals can be played around with separately. Let's focus on the upper integral. If we divide both the numerator and denominator by e to the power 4u, and this is what we're showing here, you divide the entire denominator by e to the power 4u, the entire numerator by e to the power 4u. What that means is that in the numerator, we are left with e to the power negative 2u times u over 1 plus e to the power negative 4u, because e to the power 4u in the denominator divided by e to the power 4u becomes 1, and then this 1 divided by e to the power 4u becomes e to the power negative 4u. And then now let's go and focus on this side of things. If we say let u be equal to negative u, I know what this means is that du, let's use prime here, is equals to negative du. And then this negative infinity becomes positive infinity. But here we have e to the power negative 2u. This becomes negative u prime. And then it's negative, and the negative here becomes positive, so the sign does not change. So essentially we have e integration from u tending positive infinity to 0 of this becomes negative e to the power negative 4u plus 1 e to the power negative 2u u du. So the negative from this u and the negative from the du cancel out, so we have a positive. Now when we flip the signs so that this interval, not the signs, but if when we flip the limits, then we have to attach a negative to this side. So now we do have this integral, which is the same as this integral, but opposite in sign. So what that means is this and this would cancel out, right? And that means that the answer is 0, right? So that's the answer for this very interesting problem. Looked complicated, but when you play around and manipulate things, you're able to arrive at the answer very easily. So thank you again for paying attention, for following along. If you have any question, please don't hesitate to leave a comment or a question in the comment section. We would be glad to get back to you. So until next time, bye-bye.